Hi everybody, welcome to the last tutorial for Math 1324. We're just going to talk about sequence. It's not going to be a very long video simply because we did not have time to finish this in class. So the sequence just list of numbers like this. If I ask you what will be the next number on this list or the sequence, that will be easy. But just get over some terminologies, notation. When we write a sequence like this, we'll denote this is going to be the first term, and we use the subscript of 1. This is the second term, a sub 2, and then so on. So the first term a1, and then subsequently we have that. Right. And then a4 and so on. So if I ask you what is the next number on the first sequence, maybe we see there's the parent. That is, we're going to plus 3 every time. So if we have to find the next number, we're just going to add 3 to it. So the next number is going to be 19, and the next number is going to be 22. Right, that's easy. So of course we can write that is a1, 2, 3, 4, 5, 6, 7, 8. That's a sub 8. But my question is, if we have to go to 100, then what's going to be this term here? Right. So notice that on this sequence, to get to the second term, we have 1 of the plus 3, a3, we have 2 steps, a4, we're going to take 3 steps. So to go to 100, we're going to have a bunch of steps. But we don't know that the third step, the third term, 2 steps. So we're going to have, you see, the third term 2 steps, second term 1 step. So the 100 term is going to be 99 of the step, and each step is going to be a plus 3 to it. So the total that the step that we take is 99 steps, and multiply by 3, that will be 297. So 297 plus 1 is going to be 298. So that is not even have any formula for it. Now we define properly. This is called the arithmetic sequence. Where we just add a constant from this term to get to the next. This step is addition of a constant, and that constant we define to be the common difference. And we denote that by D, the common difference. And so from this formula, from this example, we can say that to get to the n step, we're going to start from the first one, and we take the n minus 1 steps times the difference. So 1 step to the second term, 2 steps to the third term, 99 steps to 100 term, n minus 1 steps to get to a sub n. So that's what we have for the arithmetic sequence. Similarly, we have this called the geometric sequence. What we do instead of addition, we're going to multiply. It could be positive or negative. In this case, multiply negative number is negative 2. I'll keep doing that. Now if we have to go to the next term, so 1, 2, 3, 4, 5, I'm going to be the sixth term. We're going to multiply by negative 2. That gives us negative 96. So, and similarly, doesn't matter what term we get to. So if we want to get to the n term, we start from the first one, times r, times r, times r. And the step that we take is going to be n minus 1 of this. So get to the second term, 1 times 1r, second term times r again. And to get to the sixth term, we're going to take r to the fifth. So it's always 1 less. And finally, we go to the formula. And properly defined, this is geometric sequence. And the numbers that we multiply each time is called the common ratio, denoted by r. Right. So of course we have those two formulas here. Yeah, I highlight that. Right. Now we do a few examples in both of this. Will be 20, 43, 45, and 46. Actually 43 and 45 first. So this one we have arithmetic sequence. So we know we start from 24, and to get to the next number we're going to minus 3. So the next one is negative 21. Positive 21 minus 3, 18, and just keep minus 3 every time. And we wish to find the 23rd. So to get to the 23rd term, we're going to need to have 22 of this, 22 of the minus 3. So we just say 22 times minus 3 is negative 66. So from the first term of 24 go to negative 66, we're going to have negative 42. Right. So we do that even without any formula. Now if we do have the formula for that, A1 is the first term is 24. We want the 23rd term. So put 23 in for n. D is negative 3. And we have the same thing, negative 42. So either we use the formula or we just reasoning. Good reasoning, we can find that. Should be easily done. Right. The next one we might need the formula. Right. So we do know that we start with 4. And each time to get to the next number we have to plus 8. So we know the common difference is going to be 8, and we start from 4. And we do need the formula for this one. So a sub n equal to a1 plus n minus 1 times d for the arithmetic sequence. And put in everything we know. First term is 4, n minus 1, difference is 8. Now just need to multiply it out. And 4 minus 8, so an is equal to an minus 4. Once we have that, we just need to find the 20th term. So a of 20, we just need to put 20 in for where the n is, here and here. So 8 times 20 minus 4, 160 minus 4 is 156, and that's going to be a. Right. Once again, this problem does need to know the formula. We go from the first term and take n minus 1 step to go to the difference, and so that is that. Right. Go back to 45 in a minute. Let's look at 50 and 51 rather quickly. 50, we know that this is a geometric sequence because that is given, and so meaning that we need to know what do we multiply from this term to the next, and so the ratio on this one is -2, right? And then to get to the n term, start from the first one times r times r times r, and n times n minus 1 times. So pretty much we have this, and put in everything we have. The first term is 7. Common ratio is -2 to the n minus 1, and that all there is to it. So pretty much we just need to identify this is the geometric sequence. With that we need to know the ratio, and the -2 is the ratio, and the rest just that. 51 is also rather simple. We can do this without the formula actually. We start from 3200, and the ratio is -1/2, so we multiply by -1/2 every time. -1600 and -1/2. Will be 800. Half of that -400, half of that +200, and half of that -100. And yeah, like that, even without any formula. But because they only ask for a to the 6, if they ask for a to 100, I'm in trouble if we do it like that. Alright, we do know the formula for the general term though. Is a1 r to the n minus 1. Once again, the formula is on that side. So just put everything. An is 6 for n. A1 is 3200, -1/2 to the 6 minus 1. So 3200 times -1/2 raised to the power of 6 minus 1 is 5. So either way we have that. Right. So very simple. Once again, it's going to take n minus 1 steps to go from the first term to the n term. So that's why both of this formula we have the n minus 1 here. One we add, one we multiply. One we have multiply, one we have the power. Alright, next we're going to go focus on the arithmetic sequence. Before we get to the formula, of course, also on that side, just do a simple example. If I ask you what is the sum, if I add 1, 2, 3 all the way to 98, 99 and 100, even with the calculator, that will a little bit of work. What we do instead is we're going to write this in reverse. Instead of 1 to 100, we start from 100. Back to 3, 2, and 1. If we write like that, of course, doesn't help either. But what we're going to do instead is we're going to add side by side. On this side, we're going to have 2 of the sum, and then we have 101, 101, and 0. And now I think you know where we're going with this. And we have to ask you how many of this 100 do we have. Of course, that's going to be 100 of them. So we just have 100 of the 101. Right, so that's pretty simple. The only thing that we need to do is that this is twice the sum. To get just half of it, we divide by 2, equal to 50, 50. So bottom line is we arrive the formula. We're going to have 1/2, or we write 100 over 2, or we write n over 2. N is 100, the number of terms. And after that, we're going to have 101, which is the first term, plus the 100 term, in this case a sub n in general. Or we can substitute that formula up there down into a sub n, and we have n over 2, 2 times a1 plus n minus 1d. Right. So that is the sum for the first n term. The number of terms times the first plus the n term. Right, pretty much that. For the geometric sequence, there's a proof for that, but that's not very nice as this, so we're not going to go over that. With this, we do complete these 2 questions. 45. So this one we want 50 terms. Alright. So 50 terms in an arithmetic sequence, and we add all of them up. Arithmetic, that is. So first we know that what we need to do is going to plus 9 to go from this term to the next. So let's first find the 50th term. So we start with the general term. Now we find the 50th term, meaning we're going to need to find the n term and the first term and the number of terms. Most of them are given. Right. A1 is negative 10. By the way, sorry, this is negative 19, so we're going to minus 9 as a difference. So plus n minus 1. And sorry, should not do that. We're going to a to 50. The first term is negative 10, and then plus 50 minus 1, because n is 50 now. D is negative 9. So we do that. I just use the calculator. Negative 10, negative 10, plus 49 times negative 9, negative 451. And then finally, the sum of the first n term, the number of terms divided by 2, the first plus the n term. So n over 2, 50 over 2, the first term, negative 10, plus negative 451. And we do that. So 50 over 2 is 25 times negative 461. We have that. So number of terms divided by 2, the first and the n term, the last term in the required 50 terms. That is 45. Yeah, like that. And on this one, like I said, there's a proof for that, but it's not as obvious, so we just use the formula that I highlighted on that side. You can use either this one or this one. Still, just go with the first one then. So in this case, we want 11 terms, and we multiply by 2 every time. A1 is the first term, that is 2. R is the ratio is 2 also. Power 11, that's going to be 11 terms, and 1 minus R is 2. So pretty much we have everything already. I'm just going to do the math. Right, 2 times. We do have a big fraction. Actually, it's not big at all, but because that's just negative 1. So if we need a fraction, remember alpha y equal to, that would be, I'm sorry, I changed my calculator earlier. Right, again, 2 times alpha y equal to give us a fraction. So that, yeah, we can pretty much type exactly as we see it. 1 minus 2, or we just type negative 1. So pretty much that. Actual formula is straightforward. So yeah, we have the formula on that side. Just notice the formula here on that side. Either we start with 1 or we start with R. Has to be consistent on that. Right, and with that, I think we finished everything that I want to cover in class, but we didn't have enough time. Right. Thanks for watching.